Hello, everyone. I welcome you in yet another fun loving session of our ML, which is machine learning. So, I welcome you all in today's session. Let's quickly understand what we have done in the previous class. In the previous classes, we have understood different parts or different types of machine learning methods where we have put our hands on practice to predict the income of an individual. Along with, we have seen what is the difference between linear regression and multi-regression. So going forward with that, today we are going to learn and understand neural network and the role of neural networks in machine learning. So I welcome everyone in today's session, and it's all about understanding how neural network work and how we can build and train them using TensorFlow and Keras. We will use either Google Colab, or I'm going to use the same platform with which we have been doing our coding, and that is Visual Studio Code. We'll make sure that you are signed into your Google if you are working on your Google Colab. This session is a beginner friendly, so even if you don't know anything about coding, that's completely all right. And we are going to design to introduce building blocks of neural network. Before we get started with neural network, let me quickly tell you what neural network is. So basically, we have been working and we know that how a human thinks, right? It's like our brain. In our brain, we have different neurons. It's our entire brain is made up of different neurons, right? Multiple neurons, and they connect with each other to form a designated design. If I'm going to feel anything, like if I'm feeling hot and cold, right? So what is going to happen? The signals, my skin is going to send the signal to my brain by using these neurons. Similarly, the same concept is being copied for machine learning, or you can say it's a part of deep learning. Neural network works exactly same. It sends the information from one neural to another neural, and that is what it creates neural network. We are going to understand it more what is input, and it works in different layers. So let's understand and let's quickly get started. If you want to make notes, please be ready with your notebook or pen. You can make notes also. So the session objective, before we begin, let's go over what we'll achieve today. Our focus will be on understanding the structure of a neural network, exploring key components like activation function, loss function, and optimizer. And finally, we are going to build a working model using real world data. So that is what we are going to do. So today's session is completely an introductory session to understand what our neural network, how it works. And session number 2 is completely hands-on session in which you are going to create a real world data model. So the first part over here, which is like understanding part, the second is we are going to understand what is activation function, what is loss function, optimizers, and how you are going to build your model using TensorFlow and Keras. So this is what we'll be doing in today's session. Now let's understand what is a neural network. I have given you a simple glimpse of it. Now think of a neural network as a conceptual model inspired by how a human brain works. Just exactly the same way like our neurons fire in our brain, artificial neurons process information in the same manner. They are particularly good at learning patterns from the data. In the previous session, we have we have visualized multiple patterns. Similarly, here also neurons are trained to find and to process the patterns, whether it is recognizing a face or detecting a spam or predicting credit card frauds. All these are going to be done by using simple neural network, or you can say algorithms, neural network algorithms. So that is what we will be doing in today's session. So neural network basically work exactly like the way human brain works. We realize something with the help of our sensory organs. And similarly, in the same way, when we are going to train a machine, that machine also senses it and it responds the same. Now, you must have bothered and you must have thought of when you are entering into a mall, right? Or when you step onto an accelerator automatically starts. Or when you enter into a mall, then automated doors and those glasses opens. It works on the basis of the sensors are being installed in that machine. Those could be ultrasonic sensors, or you can say proximity sensors, or infrared sensors, which detects an obstacle and accordingly it performs the action. So it works on the same phenomena. All the devices, all the computer things, everything works on the same phenomena that is called IPO, input process output. It's as simple as that. Even if I'm going to ask you, how are you going to make an orange juice? For that also, you are going to apply IPO. I means input, process, output. To prepare orange juice, the input is going to be oranges. Process is going to be that you are going to either grind it or squeeze it, right? And output is going to come as an orange juice in front of you. Similarly, when you are talking about a neural network or a machine to perform certain actions, there is a need of input. You are going to give input that could be in the form of a data, pictures, or anything on which you wanted to run your analysis. And the processing part is going to happen in hidden layers. And in different layers, with the help of biasings, this arguments, or you can say all algorithms, are going to work. After that processing part, you are going to get certain output. And that output is going to be a number. On the basis of that, you will realize how much loss function is there. We are going to touch upon all these details in depth. Meanwhile, let's see how input process output works with the help of this diagram. I hope you are able to see this. As of now, with this demographic visuals, you'll be able to understand how these inputs are processing through connectivities, and all these connections are sending that input information in the form, and at the end, those two layers are your output layers. Let me explain. These two layers, the front layers, are your input. All in between these are your hidden layers, in which biasings are happening with the help with combined with weight, and at the end those are your output. Combined with weight, the accurate value, when it is matches with the testing part, then it is going to calculate the function, how accurate your value is, whether your model is and the prediction is same, is it accurate or not. And this is how a neural network works. Basically, in simple words, when you write anything in ChatGPT, it creates multiple assumptions based on that one statement. Suppose if you have written what, right? That simple what is going to create multiple layers. What is this? What is your name? What are you doing? So there could be multiple, thousands of assumptions can be made by using what. When you are doing some more and when you elaborate your prompt, it is going to find the best possible way using the weight and the bias inside it, that which matches with your answers correctly, and the one which matches perfectly and precisely close to it, that is going to be your output. This is how your machine learning, deep learning neural network works. I hope now you got some glimpse of it, how neural network works. Let's move ahead and let's see the neural network architecture. Let's break down the neural network into three main parts. The input layer receives our data. Hidden layer transforms that data through weight and biases, as I have already explained. Over here, you can see the first two are your input layer, then it goes into the hidden layer where weight and biasings are happening, and ultimately you are going to get the output. The hidden layer then transform this data through weights and biases, and the last layer, which is your output layer, produces the prediction. Every connection has a weight, and every neuron applies an activation function to determine its output. And that is the role of an activation function. Activation function actually triggers and activates. Like what? What is a trigger? And around it, all these assumptions are happening, right? It is just an example. Later, when you are going to research it more, you will understand. And definitely on our hands-on practice, when you are going to do hands-on, you'll understand each and every term accurately. Let's move. Let's understand now what is an activation function. Activation function introduce non-linearity. Why it is like non-linearity means when you have an activation function that adds non-linearity to a network like LEU. And why it is important? Without them, no matter how many layers you add, the network will behave like a linear model. So if you want like most use out of this function, the first one is ReLU is the most commonly used functions in nowadays. Now the second one is sigmoid and softmax. They are typically used in classification problems, especially at the output layer. When you are going to take out the output of it, to take the activation function and to use that from hidden layer to output, there you will be using it. Moving to the next thing, then we do have loss function. Some part of it you have already done in finding error. As you can see, mean squared error that we have already done in linear regression and multi-regression, and measures how well the model is performing to calculate the value from actual to the predicted value and to minimize that loss. The loss function tells how far off it is from the actual results, means the testing results as well as the predicted value. It is critical component of training. Different tasks use different loss functions. Let's say, for examples, for predicting categories, we use cross entropy losses, and for numeric predictions, we use MSE, means mean square error. These are the functions which we use, and some of it we have already been used. And its role, majorly the role of it, you are going to find in back propagation. In deep learning, in detail, you are going to understand what is back propagation, what is forward propagation. Moving to the next one, we have optimizers. Optimizers decide how the weight in our models are adjusted during training. Think of it as trial and error. Like Adam is one of the most reliable optimizer and genuinely a good default. Others like SGD and RMS prop, these are having specific use cases, especially for a very large data sets or advanced churning if you need. So in that cases, it will be. Otherwise, you have usually, like if you are going to work with Adam, I think it is going to provide a great result to you. We will be using all of it when we are going to do our hands-on. As of now, I'm just making you familiar with all these terminologies and how you are going to use where it is necessary. Moving. Okay, everyone. So we have understood what optimizer does by actually deciding the weights in the model. It adjusts the training level and provide you minimum loss function to give an assumption that which one is the correct predicted value. So you must have seen in your mobile phones where you have Face ID. So how it detects? It basically detects your features, and for example, let's see, आपका face है. When you detect it, when the camera rolls onto it and it sees, then it sees each and every pixel. Like in computers, everything work on pixel. So after, like, in which part your pixel is accurately mapping with it, and they take the closest and the precise value of it. And similarly, on the same way, your Google Photos work, where it shows the recommendation that this person is you, right? And this is how face recognition happens. I'm going to give that example among all of you. Before that, let's see what more applications of neural networks are. So basically, face recognition is one, and then real time translation. Suppose, like I went to Russia And there, all the people, they are communicating in Russian language. Their regional language, whatever there is, their native language is Russian. And I do understand only in Hindi and English. So there was no one to communicate with. So what I did, I took help from Google Translator, which was translating each and every word by word. And in fact, if I'm like putting my camera on, so whatever was written, the text was also in real time was converted into English for me. So it makes my life very easier when I was in a different country where the language was not familiar with me. Same example, the shape of the letter, exactly how many number of pixels were included and precise value of that, mixing the weight and the biases, it calculates. Now let's see, I'm going to give you an example. Suppose you have provided three shapes to a machine. One is triangle, then a circle, and a rectangle, right? Now you have trained your machine to identify these three shapes. Now for testing, you are providing circle shape to your machine. Now let's see how it is going to calculate. So over here, this is how neural network works. So basically, this entire segment is filled with pixels, and you can see that it's a grid of 28 by 28. When it is going to receive, you have shared the input. Now it is going to share and it is going to use that into forward propagation, where you can see that there are no pixels left. In between, if you are going to check, there are no pixels left, and that the same information is going to propagate it further. You can see all these x into zero point 0.8 and then x into zero point 0.2 is equals to b. That is your activation function. Activation functions accurately defines how close your value or the figure is to the trained value, and then it recognizes it. Now you can see the actual output and what exactly is the error. That error, minimum error you are going to get, that is going to be your precise output value. This is how you are going to calculate this value, and this is how it works. Now neural network work exactly in the same pixelate function. It is going to recognize my shape, my face shape. Now at every pixel there are certain values to it. If my eyes is in this much of shape, right, or little bit, the features of my shape are accurately, it's like my nose is like 3 pixels, or you can say 30 pixels each side away from my eyes. So that is going to be same, it cannot increase to 40 or 50, correct? Then it is how it recognizes the feature, and activation function works, that is a formula which works to recognize whether the shape is similar to the trained one or not. And this is why we are using multiple models to run these calculations like ReLU, Adam. So these are all activation functions which helps to recognize the patterns. And these models, so basically when we talk about neural network, TensorFlow, Keras, these are not just to create a model for developer, these are to minimize or reduce the complexity for the user so that they can develop it in a better way. Now let's understand one very important part. When we talk about neural network is actually a part of deep learning, and deep learning is actually a part of machine learning, and machine learning is part of AI. That is what you are going to keep in your mind. So when you are, entering into the world of AI, everything you see, if we are going to deep down into the depth where facial recognition, deep learning, text recognition, NLP, natural language processing, these are all part of deep learning, which is a subset of machine learning. And overall, if I say all of this, which is to imitate human experiences, to actually copy or implement those experiences or mimic human behaviors, that is what AI is all about. With that, let's quickly wrap up our today's session. In today's session, we have understood how neural network works, With neural networks, we have understood how you are going to calculate how face recognition is happening, how text recognition is happening. We have understood different layers which are helping us to provide input, process, output. Everything works in the same way. So I'm going to just quickly share that loss function in front of you. As you can see, loss function tells the model how far off it is from the actual result. So when you talk about facial recognition, if you have put multiple inputs in it, it is going to find the most close value which it is going to be trained upon. And that is by minimizing the loss function. So loss function predicts which one is closest, the precise actual value. And with that, we have understood optimizers, different sort of optimizers we have learned over here. If I'm going to say optimizers decide how the weight of our model. So basically, if you are confused, what are weights, what are biases, please feel free. It is like how much it is the closest value. So when you are putting the weight, every pixel and every node. So in machine learning or in deep learning, every neural net has different nodes of it, and every node has a value, and that value is known as weight. When that weight mixed with biases, add on to the biases, it creates a value, and that value is going to be fed into activation function or activation formula to provide you a value which is close to the actual prediction. So that is what is being like, this is at the back end how machine learning runs the model, what is exactly matriculation is happening at back end. So these are all models which we have discussed. I hope you have understood and you have taken a lot from today's session. I know it was a bit technical. If you are going to research it a little more, you will understand it in a better way. In case if you still have any doubt, we'll be seeing you in the next class. And make sure in next class you are going to come prepared. We are going to get started with a model on TensorFlow as well as on Keras. That is what we will be covering in the next class. So hands-on activity in the next class, I'm going to give you again a better exposure in terms of how you are going to create data set, a random data set, a structured data set by using code only. So we are going to use NumPy for that. We are going to install pip install in our command prompt or terminal. We are going to install our TensorFlow library. And with that, we are going to create a prediction model the way we have created previously. But make sure that you remember all the steps which are included in creating a machine learning model. So I'm just going to reiterate all of those. Number one is you are going to fetch the data. Number two, you are going to visualize the pattern in the data. Number three, after visualizing it, you are going to split the data into test and train. Once you have split the data into test and train, you are going to train the data. Once you have trained it, you are going to evaluate it. Evaluation means you are going to test it. Once you have tested it, you are going to publish it. So all these steps, please keep with you, because all the models are based on these simple steps. Only the calculations at the back end and the model or classification which you are going to put in, that is going to be changing. So stay tuned with us. We are going to see you in the next session. Thank you, everyone.